So this axle is assembled out of the Trotec. That's the card it comes on. It's got plastic, it's got acrylic stub axles, which work just as well, but on the big vehicles I prefer to use brass or nickel silver. What this includes, just to be clear, is the top and bottom of the axles, spacers that go between the top and bottom and gap it out, and then side plates which are a nice cosy fit in there, and once glued in hold the assembly neatly together. And if I can just very briefly put this together without knocking the camera over. What we have here is right, and this 1mm wire is bent to act as a kingpin, but also more importantly, it takes the load, so actually the plastic really isn't doing very much work at all. It's the wire that is doing the main work, and I've fitted here a double-sided stub axle, so I can have a track rod on one side and the steering arm from the front, and I would do that purely because the servo position would suit that better. So, and the second one was as simple as that. And you can make it left or right-handed simply by turning that upside down. So you can hand them however you please, like that. And then the last thing will be to mix up a little bit of epoxy and just run some epoxy very carefully in over the top of that wire on both sides, and that'll secure that nicely in position. And you've then got a really nice precise axle at 33mm between kingpins. And before I go any further, I'm actually going to check to see if it's the right spacing for this particular vehicle. So here's the axle with kingpin wires fitted and glued, and that's your double-sided and that's your single-sided. These are sized so the bearings will hopefully just push on like that. They can be retained with the teeniest amount of epoxy, but don't go overboard. So the next thing is the track rod. Now, one of the laser etchings is a track rod. That track rod there, and that has obviously a hole at both ends, but also a hole in the centre, well, not in the centre, but in between, for a drag link to go to the servo. So your servo is mounted there, and you'd have a rod between your servo arm and the track rod, and that's what that hole's for. You don't have to use this, of course, because in order to link those together, you would need a short bent piece of wire with a washer on top. There are washers. Here's a washer. These are the washers. Bang, bang, bang. Washers there. What I tend to do is use 0.8mm wire, put a bend in the end like that, and then just using a pair of pliers put a similar bend in the other end to match, so that actually we end up with a wire track rod like that, which has bent up stands exactly the same length as those holes. So I'm not going to use that. So that wire track rod can fit in the axle like that, and then to retain that, use these laser cut washers, one on each, and then there are extra ones just in case they ping across the room, as these things do. So I'm just going to put this, whoops, very briefly in the vise, so I don't have to hold it like that. Like that, and I will mix up the teeniest spot of resin epoxy to retain it. Bear with me while I just do this. Right, just mixing that now. Superb. And just put a spot on the wire going down to the track rod. Same on this one. Teeny spot more. That's it. And we'll let that dry, and then that axle is just ready for the bearings to be fitted. So we've got each end captive there. So that's then ready for bearings fitting and wheels fitting. And then we've got to carve a hole for the axle in the chassis, and that'll be fun. Here's the finished axle with the wheels now glued on to the bearings. Now, whoops, steady. tyres are loose on the wheels. Now, as you can see, that very freely articulates there, and there is not much movement in that plane. What you see there is actually in the bearing itself rather than anything else, and that's quite acceptable. The only thing I would say when gluing things like wheels on and bearings on, when you're gluing the bearings onto the stub axle, put a little bit of glue in the bearing and let the stub axle push it through, and that way you won't get glue interfering at the back of the bearing and the stub axle. And similarly, when you're gluing the wheel onto the bearing, apply the glue to the outside of the bearing and then push your wheel on, so the excess glue gets pushed back out, rather than if you do it the other way around, and if you applied the glue to the inside of the wheel, the bearing would push it in, and doubtless you'd get glue on the face of the bearing and in the ball race, and it would stop it working properly. So always have a think about where you want your excess glue to go, and that'll dictate where you want to, what surface you want to put the glue on, and that will keep it all nice and running smoothly. So that is the front axle assembly for the BMC Leyland Thrupenny bit cab. This is actually 33mm between kingpins, and if I just get an untouched one here, hold that up, you'll see that actually the track is about the same. I'd be struggling to get it much closer, so 33 will be fine for this model. So now in the chassis I'm working on, I've got to cut a hole or cut a slot in what is at present the sump for the axle to sit in. That's the next job. Okay, so here is the front axle fitted. There's the sump being cut away with the slot just over 3mm wide there, and that was done with the old combination of chain drilling and with a slitting saw in the Dremel. And then the frames were also cut away slightly. You probably can't see, oh you can just see. The frames were also just cut away slightly, about 3mm on the same trajectory, so the beam axle is free to disappear up. So that gives lots of lovely articulation, which is what we want, and easy articulation as well. I've also carved away a slot there for the track rod to drop into nicely without fouling anything, and in order to get the pivot where I wanted, I had to carve away a hole in front of the sump and carve away a semicircular passage, as it were, so I could actually put a 1mm drill right down there without snapping it, straight and true, and drill the back face of the sump and introduce a piece of 1mm bent wire to act as the axle pivot, and indeed you can just about see the end of it is bent up, and it goes about 4mm into metal the other way, so most of the work is done. So I'm just restraining that end with a little bit of my favourite Devcon epoxy. But that then gives us a chassis that can be powered simply by dropping the motor in, and can be steered now by chopping a section of the front out in order to fit the servo. Obviously it will go vertically, probably like that, and probably somewhere around there, and there will then be a link between the servo arm and that double-ended stub axle there, and that will then steer very nicely and give the usual characteristics of having all 4 feet on the floor and nice realistic motion. And here we have the modified chassis with the cab put back on. If I just move the wheels, you can see that has quite a nice realistic stance to it, and the same on the other side. And the turning circle is quite appropriate, I think. So that's going to be a good job. That's coming on fairly soon. I hope I shall have a chance to pop the servo in and connect it up mechanically, and that's most of the job then done.